All right, in this video, I'm going to be recording solutions to BC Homework 2.3. This is the first homework on chain rule. And I do have extra examples for this, and I think I'm going to record that as a separate video. Okay? So the first set of problems is just find the derivative using the chain rule, so let's get to work. Let's say 4 times 3. Okay, I'm saying that the outside is the 3 times the thing to the fourth. So f prime is going to be 4 times 3 is 12 times that thing to the third times the derivative of the thing. And so that's 2x to the 3 plus 1. Its derivative will be 6x to the 2. Over here, I've got a product situation, but the second factor is got chain because it's 2x to the 3 plus 1 to the fourth power. So g prime of x, I'll start by taking the derivative of the easy one, right? So, and then I'll leave this thing the same. So I'm doing the product rule. I'm going to add in, leaving 3x the same, the derivative of this. Well, the derivative of a thing to the fourth is 4 times that thing to the third, maybe times the derivative of that thing. Okay, times the derivative of, yeah, this is where I'm taking the derivative of the inside. That's going to be 6x to the 2. That's kind of a lot for a derivative, but that is a formula that it is going to work. All right, this one I'm going to have to rewrite. I see a square root, I see a cube root, really see any kind of radical. I need to rewrite that as a power so I can use power rule. So h of x is 6 times sine x to the 1/3 power. Okay. Now I'm going to take the derivative, starting with the power rule, starting on the outside, and then working my way in for the chain rule. H prime of x is going to be 6 times a third is 2, times the thing to the 1/3 minus 1 is 1/3 minus 3/3 is negative 2/3. And I'll have, leaving the inside the same, and then I need to remember to multiply by the derivative of the inside for the chain rule. Y equals 6 sine of the cube root of x. Okay, again, this is going to be the outside, and this is going to be the inside, so that's going to be the difference here. All right, so y, I'm going to rewrite it. Okay, so that y prime, or dy dx, is equal to, start with the outside. Well, the derivative of 6 sine of t is 6 cosine of t. But then I need to multiply by the derivative of the inside. So x to the 1/3, its derivative is 1/3 x to the negative 2/3 for reasons I discussed over there. And so that's going to be, leaving the inside the same, I'm going to have that. And you could definitely combine these and put that in the denominator if you wanted to, but you could also not. Right? U of x is equal to fraction to the 3rd power. All right, so I'm going to just attack this, from the outside in. I will have to use quotient rule, but it won't be the end of the world. If you wanted to write this as x to the 6 divided by x minus 1 to the 3, and then take the derivative using the quotient rule and chain rule, be my guest. You're going to get the same thing. So u prime is, well, the derivative of a thing to the 3 is 3 times that thing squared. Then I multiply by the derivative of the inside, which is the derivative of that fraction. So it's bottom. Wait, hold on. Bottom times the derivative of the top. So that's times 2x minus the top times the derivative of the bottom divided by the bottom squared. All right. And that's, that's a formula. It's pretty ugly, but it will work for us. All right. V prime of x, okay, I'm going to have to, I already know I'm going to need, well, maybe I can just write with a, zoom in and write with a thinner implement. This is going to be a pretty long one. So I'm going to start derivative of x and leaving secant the same. So v prime equals 1 times secant of 2x. Plus, I'm going to add in, leaving x the same, taking the derivative of secant of 2x. The derivative of, maybe you forgot, the derivative of secant x is secant x tangent x. So the derivative of secant of 2x will be secant 2x tangent of 2x, but then I need to multiply by the derivative of the inside for the chain rule, so that's times 2. And that's v prime. That was just kind of a lot. I definitely wouldn't have fit it in there if I was still using a felt pen. So zooming back out, moving along. All right, e to the 2x minus 1 over log x. Okay, with fractions, especially if it's 1 over, I'm going to just recommend you write it as the negative 1 power. So I've got f prime equaling, okay, the derivative of e to the 2x is e to the 2x times the derivative of 2x. And so I'm going to say that's, okay. So when I do the derivative, I start with the outside, that's the power. Negative 1 times this negative becomes a positive. Log x to the negative 2. Then we need to multiply by the derivative of log x because that's the inside for the chain rule. Right? Okay, I'm going to rewrite this one as a power before I start it. I'm going to then take the derivative. Okay, I'm going to start with the outside. That's the power situation. That's going to be 1/2 times that thing to the negative half times the derivative of that thing. And I'm realizing now that there's no way, because the derivative of cosecant is negative cosecant x cotangent x. All right, so there's the negative cosecant 4x cotangent 4x. Then we need to multiply by the derivative of the 4x for the chain rule, because this one's got, an extra layer. Okay, but I need to make sure that I've left this inside unchanged. All right. And I will just tell you right now, if you're watching, this is more intense than any, derivative than we are going to need to do this year. This is just getting you comfortable and familiar with the chain rule. Tangent cubed of pi x. Okay, multiple layers of chain are really uncommon in AP calculus, but they're not. It's not unheard of, and it's definitely something that if you're taking this class at a university, they would definitely be hitting you with chain rule problems that had multiple layers of chain for sure. Right. So I'm going to say that's tangent of pi x to the third. Right. So I'm going to say that h prime is 3 times tangent of pi x, leave the inside unchanged, squared, times the derivative of tangent of pi x. So that's going to be, derivative of tangent is secant squared, leave the inside the same, then multiply by the derivative of the inside, and that's going to give me an extra pi right there. Okay. K of x is sine of 2x cosine of 3x. So there's going to be product because of the sine times the cosine, and there's going to be chain because of the 2x and the 3x on the inside of the trig function. So this should be exciting. I might switch to a pencil and go down here. K prime is equaling, okay, I'm going to start with the derivative of this thing, and the derivative of sine of 2x is cosine of 2x multiplied by 2 for the chain rule. And then I'm going to leave cosine of 3x the same. Then I'm going to add in, leaving sine of 2x the same, taking the derivative of cosine of 3x, and that's going to be negative sine of 3x multiplied by 3. So I'll just put that negative and that 3 here. And I'll have cosine. Wait, no. I take the derivative of cosine, I got negative sine. So I need to get that and say this is going to be a negative sine of 3x multiplied by 3 for the chain rule. Okay, that's the end of the first page. All right. Now, looks like we're on to some other problems. All right. write an equation for the line tangent to the graph of y equals 3 e to the 5 times x minus 1 at the point where x equals 1. All right, so I'm going to need a point and a slope. So we'll start with a point. X equals 1. Y equals 3 e to the 5 times 0 is e to the 0. That's just going to be 3. Then I'm going to have a slope, which I'm going to need to take the derivative, right? And honestly, I'm going to rewrite this as 3e to the 5x minus 5. Not sure why I put it like that. I don't know if I copied this from maybe Classroom or where I got this problem from, but I'm going to say that y prime is equal to, well, you know, e to the u is its own derivative, but, you know, if u is in terms of x, then we might have to multiply by the derivative of that for the chain rule. So this is going to be 3e to the 5x minus 5 times 5 for the chain rule, because the derivative of 5x minus 5 is 5 minus 0. Okay. Meaning that where x equals 1, y prime is going to equal 3 times e to the 0 times 5, which is going to be 15. So the equation is y minus 3 equals 15 times x minus 1. All right, here we've got another one, a horizontal tangent. So you know that when you see that, that means we're going to take the derivative and set it equal to 0. And in order to find out where the derivative is equal to 0, we're going to need to find out what is the derivative, right? So I'm going to say f prime of x is equal to, I'm going to do product rule. And I think I'm going to do this one first. So the derivative of this piece is 2 times x plus 1 to the first power times the derivative of x plus 1 for the chain rule, which is just 1 plus 0. Okay, so, and I need to leave 2x minus 3 to the 3 the same. Now I'm going to add in, leaving x plus 1 squared the same. I'm going to have to multiply by the derivative of this thing. Well, that's going to be 3 times that thing squared. And then I'm going to have to multiply by the derivative of the inside, which is 2 minus 0. That's going to be another 2. Okay. So I need to figure out where this has a horizontal tangent, and I need to figure out where this is equal to 0. So this is a situation where we need to simplify. Like, otherwise, we're just not going to have any chance. And if this is going to be a high-degree polynomial, like at least 4, right? Yeah, it's 4. And so what we'll do is we're going to factor this thing rather than actually distributing. That would not be the thing to do, right? So we're going to factor it. Okay, I've got a 2. I've got 1 power of x plus 1, and I've got 2 powers of 2x minus 3. Right? Yeah. I have 3 over here, but just 2 there. Just 1 over here. So, and then I'm left with, I factored out everything except for one last copy of 2x minus 3 here. Plus, and then over here, I've got 1 copy of x plus 1, factored out both of these, factored out this, I've got a 3. So I've got 3 times x plus 1 equals 0. So obviously, you know, I think, well, maybe I'll just copy it. I need to combine like terms. I don't think there's anything obvious there. And then, okay, so this is 2x plus 3x is 5x. Negative 3 plus 3 is 0. All right. So I am going to have a solution of x equals 0, but it is not coming from that 2. It is coming from this x. Yeah, I saw that mistake a couple of times on a recent quiz. Something factored, and it had a coefficient that was able to be factored out of each term. And people said that that indicated a 0 at x equals 0, and that was not true. Okay, so I just wanted to point that out. X plus 1 equals 0. 2x minus 3 equals 0. And these are my locations of a horizontal tangent. All right, and then here we've got some table questions, and that will be helpful, I'm sure. All right, so h prime, and I need to find h prime of 3, so I need h prime of x. Okay, So h prime of 3 is g prime of f of 3 is 2. Okay, yeah, cool. I have f of 2. No. F of 3 equals 2. Okay, times f prime of 3. Okay, g prime of 2 is -1. And f prime of 3 is -3. Okay, prime of x, I'm going to start from the outside. The derivative of f is going to be f prime, leave the inside the same, and then multiply by the derivative of the inside. Okay, so k prime of 2 is f prime of 2 squared times 2 times 2. All right, so I've got f prime of 4, that's -4, times, that looks like 4 to me. All right, and then I will, okay, f of x. Okay, take the derivative of the outside, leave the inside the same, then multiply by the derivative of the inside. And q prime of 2 is going to be f prime of f of 2 is 4 times f prime of 2. Just plugging in there. All right. I lost myself. Oh, I'm just going to look these up off the table. F prime of 4 is -4, and f prime of 2 is -2. And then this is equal to g of x to the 1/2 power, maybe like that, so that r prime is equal to 1/2 times that thing to the -1/2 times the derivative of that thing. That's just going to be g. And then I'm going to have r prime of 3 equals 1/2 of g of 3. Yeah, you can still see that. G of 3 is 4. And then g prime of 3 is -2. Okay. All right, and then f of x squared. Okay, that'll be a good one. You can't see the table anymore, but you can just trust me, I guess. Okay, the derivative of a thing squared is 2 times that thing to the first, maybe times the derivative of the thing. All right, and p prime of 4 equals 2 times f of 4 times f prime of 4, and hold on. Oh. So f of 4 is looking like 3, and f prime of 4 is -4. So that's 2 times 3. I know you can't see this, but I'll show you in a second. Yeah. All right, now we've got a graph situation, and I think I've got maybe the same graph but more questions about it on the extra practice, and I'll just be labeled more chain rule examples on my channel. Suppose h is g of f of 2x. Write an equation for the line tangent to the graph of h at the point where x equals 2. All right, I need a point. X equals 2, h equals g of f of 2 times 2. All right, so I need to find f of 4. F is the darker one. So it's 1, 2, 3, 4. That's a height of 3. G of 3. And that's, I'm going to run out of room, so I'm going to need to go here. What is g of 3? 1, 2, 3, up 2. Okay. So that's 2, 2. Okay, now my slope, h prime is equal to, take the derivative of the outside, leave the inside the same. Take the derivative of the inside. Well, the derivative has an outside and an inside, so that's f prime of leave 2x the same, and then multiplied by 2 for the chain rule again. Okay, so h prime of 2 is equal to g prime of f of 4, which is going to end up being g prime of 3, because it was g of f of 4, now it's g prime of f of 4, so like that. Then f prime of 4 times 2, which is looking like, okay, g prime at 3, g is decreasing 3 each time x increases by 1. So I've got negative 3. F prime at 4, 2, 3, 4 is looking like positive 2. And then times 2 again for the chain rule back here. All right, now I've got my equation ready. Oh yeah, because this is negative 12. So I've got y minus 2 is equal to negative 12 times x minus 2. All right. And if u equals g of x, find the value of u prime of 3. So u prime of x is equal to take the derivative of the outside while leaving the inside the same, then multiply by the derivative of the inside. All right, so u prime of 3 is equal to g prime of g of 3, which I think we saw up above was 2. Yeah, right, g of 3 equaled 2, and yeah, that is true. Times g prime of 3. So it's g prime of 2 times g prime of 3. All right, and if I've got something else to say. All right, yeah, I do. I need to actually look up g prime at 2. G prime of 2 does not exist. So g prime of 3 is undefined. All right. Last one. Yeah. Oh, and I've even got a good suggestion on this too. All right, but I feel like this has been a pretty solid set of practice problems, honestly. But I'll show you where to get more practice in a minute. All right. So write an equation for the line normal to the graph of y equals e to the square root x at the point where x equals 16. All right. So I'm going to take. I need a point. It's going to be x equals 16, y equals e to the square root of 16 is e to the 4. Okay, the slope, I'm going to rewrite this as y equals e to the x to the 1/2, or maybe e to the x to the 1/2. Might be a little easier for you to look at. Okay, we know that e to the thing is its own, e to the u is its own derivative. But with respect to x, I need to multiply by du dx. So it's going to be e to the square root x, e to the x to the 1/2, times the derivative of x to the 1/2, and that'll be 1/2 x to the negative 1/2. Okay, and that's equal to dy dx. The value of dy dx at the point where x equals 16 is going to be e to the 4 times 1/2 times 4 to the negative 1/2. And, okay, so 4 to the negative 1/2 is 1 over the square root of 4, so that's 1 over 2. So this is looking like e to the 4 divided by 4. Okay, so the equation is y minus e to the 4 is equal to the slope. Okay, so e to the 4 divided by 4 times x minus 16. And that's all the problems for this one. If you still feel like you need more practice, look for the video on my channel called More Chain Rule Examples. That's going to be reworking the extra practice problems that you see in your notes packet if you're in my class. And if you still need even more practice, I've got a multiple choice booklet, and you could find chain rule problems in there as well. But that'll be all for this video.